Hello everyone, welcome back. So today we are going to understand Leetcode problem number 3459, and we will solve in such a way that you can understand easily and you can try by your own if you understand the problem and the approach. So let's understand what we have given. We have given a grid. Let me show you how, like this. Okay, you can see here. So this is what we have given. We have given a grid of numbers, you can say, and each cell has either 0, 1 or 2 as a value in this. We want to find the length of longest V-shaped diagonal segment. Okay, what we want to find the length of largest V-shaped segment. And so what's a V segment here? What are V-shaped diagonal segment here? Very first, as I told you, we have given the grid, right? So there is some couple of rules are there. So V-shaped diagonal is defined as what? It is saying the segment starts with 1. First rule is that the path must start with 1. Okay, and then it must follow the repeated value 2020, like that. We can move diagonally. It's called, if you want, like this direction, this direction, this direction, this direction. These are the directions we have given, or you can consider like this. Okay, any of this you can see. So when it is saying, when you start, when the segments start along a diagonal, right, directions, any of these directions, right, and continue the segment in the same direction, okay, and makes at most one clockwise directions, 90-degree turn, to take another diagonal direction. Let me show you how. So if you see here, right, I just told you the very first, the path must start at 1. So it's starting at 1, right? Then it is saying that it must follow the pattern 2020. It is forming. Okay, very first it should start at 1, and then it must follow the repeated pattern from 2020 and so on. This can be infinite path, you can say, but we have to move diagonally like this. You can move like from here to here, right? Means top left to bottom, down directions, you can say, and you can say the right, top right to left bottom, you can come, and so on. The directions are given, you have seen, right? So here is the twist, we are allowed at most 90-degree clockwise turn along the way, right? And the answer is the maximum number of cell we can collect over this rule, right? We have to find. In this case, you count here, the cells are 1, 2, 3, 4, 5, and that is why we are getting 5 here. Understand? Now understand, if we will solve, let's suppose ABC code we will write for now, and it will work. So how we are going to implement that code? So question is, how do we solve it for any grid, right? Think of it as a control walk, you can say. For every one, we try walking in each of the 4 directions. So when we come here, we'll find this is 1, and so for every one that we have given here, we will try, we we will try walking in all the 4 directions that we have seen. So at each step, the number is posted by the pattern, right? If it doesn't match, we'll stop it. Otherwise, we will continue. So we also keep track of whether we have used our allowed turn. If not, we can turn clockwise once and we'll keep going. Very first, let's suppose we found the 1, right? So we try walking in the 4 directions. One of the directions we found 2. So we'll say the pattern is there or not. 2 0. We have 2 0. Then we'll uh, then we have to keep track of what whether we have used one allowed turn or not. So we'll take from here. We will take one turn and we'll say yes. If we have not gone the turn, right, we can say we can turn the clockwise directions, right? So we have not gone till the any directions. We'll take a clockwise directions 90°, and then we'll move in this direction, and we'll see 2 and 0 is coming, means we'll keep track of that. And this will form the state machine where we can say column is there, a row is there, column is there, and direction, and the turn that we have taken, and the expected numbers we have, right? So that we will use, and we'll say okay, we have formed the state machine. Okay, so we will recurse with the memorization, so that as we know, we have to try for everyone that we have given in this grid. So we will recurse this problem, right? We'll do the recursion, right? And we'll try to find the maximum length, right, or longest diagonal segment, right? We have to use the recursion and we'll use the memorization. So if we revisit the same state, right, we don't recompute. Okay, so let's try to understand now the approach. So as I told you, right, the things that we have given, we will try for all the ones, right, and we'll try to form the state machine, right? Understand that a state machine. So the state machine, if we are going to form, right, where each stage state is what? We'll take the row, there will be column, there will be directions, we can say, and where we have turn, right, yet or not the flag, and there should be one more value, that is the expected number, right? If we have everything, right, in the state machine, row, column, direction, have we turn or not, and the expected number, if all of these we have, then we can track everything, right? And we can form the state machine that will track everything and we can understand. And this is what we will use the recursion, as I told you, and we'll use the memo. Okay, now understand the how we are going to implement it, right? So very first, think about this, right? So we should loop, let me clean it, I think you will understand. Now think that what we have given here, right, we have given the grid, we have to loop over what? Over every elements, not element, we can say in this case cell, we can say. So we should loop over every cell, right? So here we have to check if it's 1, if it's 1, start exploding. When we found 1, we'll start exploding, right? Then we can say you should try all the 4 directions, try all 4 diagonal directions, we can say, from the cell, that cell, right? From that cell, we can say, right? We'll talk about this cell and this is the same cell. Then what we should do? Think. As I told you, we have the state machine, so we should use DFS. DFS will give you the recursion, right? We'll use DFS recursion with memorization. Understand? So when we'll use the recursion, we can use DFS with memorization. Okay. So we'll keep walking along the path, right? We know we have the row, we have column, we have direction, we have and turn it, and what I told you, the expected number. So this will work for us recursion. Only each time row or column we have to change and the directions, and we know have we turned it or not, expected value coming or not, right? Like that we will check. Then think that at each step either keep going straight, or if haven't turned it, turn once, right? So at each step we will do, at each step we'll keep going straight, or we'll check if we have turned or not, right? If we have turned, right, it's good. Otherwise, try once. Can we say that? Then what we should do? We should take the maximum all the time, right? Take maximum path length, and we find this in how many times, because this is grade, so it should be efficient. We'll take O of m cross n, and what is the maximum is coming, maximum between m cross n will be happen, that will come the maximum of what is coming, m and n. So this code will work in the given constraint, so we'll try to implement it. You can also try the two approaches that we can say, the brute force DFS, where you will not use the memorization, right? Without memorization you can use it, right? And you can also use dynamic programming by pre-computing alternate sequence, or you can take the even VFS. So that approach you can try. Okay, you can pre-compute the alternate sequences, right? Or you can use even the BFS. Okay, brute force is good. You can use the brute force without the memorization, but they are either slower or harder to implement, right? And so I'll suggest use the DFS recursion plus memo. This approach will give you a cleanest way of writing the code, and it is most practical. Okay, now think yeah, that's all. Let's DFS+memo will do, and we'll try to implement. Let's go to the code base. Very first thing, what are the things you have given, right? So let's try to understand. Okay, I'll say the given things that we have given. Let's write, we have private, final, int, and we'll take the 4 directions like this. Directions, let me say, and this is nothing but we'll define all those directions. Let's understand. We have very first is -1 and 1, right? So what we can do, we can take in the pairs also, you can take the in the pairs also, but I'll just try the old way. Just I will update the value. Okay, very first we'll take -1 and 1, then we should use both 1 1, then 1 -1 will take -1, and then we should use it should both should be the minus, right? This is what we have in the all the 4 directions, right? Okay, now you can see. Okay, so after the format looks good. Okay, let's continue further. So next what we should do, we have directions, we have, right? We thought to create one memorization, right, table. Let's create the memorization table. let's say private, and this is what we have. So we'll take an integer type, integer, and we'll define the array. For the 4 directions, we'll use the 4 directions, right? We'll keep, but at all the 4 directions we have to define, so we have to take one more here. Then think we'll use very first, we know that here will be, let's suppose we have memorization at I, this will be about j, means the row, column, and when I told you have it turned or not, right? Turned or not, turn it or not, right, we can say. And then what we have, the expected number, right? Expected number is there or not, right, we can say. And this is what we have, the direction. Okay, we'll use, you can, for now to understand, you can say row, and you can say for now is column. This is what we will use for the memorization. Okay, and we say that, let me remove it back, and we'll say it memo table, you can write it here. So we'll pass this turned it or not. Let's suppose this could be either will pass 1 or will pass 0. The expected value will check, will pass the expected value, there will be some hash number, will say, right, that is our expected number, and this will be our directions that we are passing. Okay, we'll use the directions from here and we'll add here. Okay, like this. Then other than that, what we should do, we know that we have given this grid, so let's take the grid outside also. So we'll have one physical copy and we'll update each time, and so we'll say okay. Then we'll take we have to define the private attribute, and similarly we have to define two things, the m and n, the row or column we can say, or you can say either row and column also, right? Private, and we'll say int, we can say the row, and I'll say the column. Can we say, you can define as m and n also. Okay, this is what we have in this question, right? And we have to find the argument that we have given is grid, right? Very first, what you should do, you will write this dot grid, and then you will write the grid. Can we say that? Similarly, you have to find the row, and to find the row you will say that this dot row is nothing but what, grid dot length. Similarly, you will find this dot calls or columns, you can say, you can write the full, but we write columns, those columns, columns. Okay, how many columns we have, we can get from where, read at 0 and to 10th. Like this we will initialize the value. Now it's time to understand for the this case that we have talked about, right? We know we have to pass row, column, this and this. Okay, so for now I'll take this now, and how we are going to implement it, we'll say initialize it, we'll say memo, and at the memo it should be in new integer. We have taken, that is why we have taken integer, we have to initialize it. Otherwise, if we'll take the int, we have to assign some value, right? We'll take integer and we'll add the value here. We'll say this is nothing but our rows, this is nothing but our columns, and this is nothing but we'll take for now, let's call the very first value we have, we can take what we can take, think So we know that this is what we have because we have the current cell we have, right? We need to know where we are, right? With the we can say with the row and columns, right? So that we can get from here. We have initialize. What we will initialize this value? This is we have the turn yet or not, right? The possible values is either 1 and 0. Okay, so we have to add here, like, because it is turned or not means we have we already used one clockwise turn, right? So what are the two what are the possibility? So there is only two possibility: 0 not turned and 1 is already turned. And that's why we need to we need the third dimension, that is called 2. Okay, I hope you understands. Then what we should do, we know the expected number. So expected number, what are the expecting number in this cell, right? The sequence alternates are maybe after 1 it must be 2 and then 0, right? Then we will use 2. So at any point the expected value is coming either 2 or 0. So that gives you the two possibilities, and we'll say okay, having two possibilities, so let's write 2. So we don't need to track 1 here because DFS starts after the initial one, right? So then we'll know, then 2 will come, then 0 will come. Remember that we will think. Now at the last, we know we have to write the directions, the diagonal direction we are moving, right? So there are 4 directions, right, that we have seen. So we'll write, let's the 4 directions we will write. Okay, the possibilities are we'll use the 4 direction, right, where we'll we have seen, right? So we stored which one we are currently moving on, and so the last dimension is 4 we'll use. Okay, so now this is the things we have initialized. So what do you think, what we need next? One value we have to write. We'll say we'll take the int max length, right? Max length, and this value will initialize from 0, and at the last we have to return it, right? So let's return it here. Return max length, length like this. Okay, and here you have to write the logic. And to do that, you can pause and you can try by yourself. Let me write for you. You know we are on the grid, so we'll use int I is equal to 0, and we'll go I will go for all the rows, and I plus plus. Then we have columns, so we'll use columns, not for columns, we'll start from int j, let's suppose, right? I and j, and the j should be less than, for now we can take how much columns, right? Forget that, columns, and j plus plus. Can we say that? So this is what, this is the normal thing that we need to. Now we have to find the very first that was given. We have to start for all, we have to start for all the ones. So we'll make the condition and we'll say, do you have the grid at I and grid at j is what? The cell contains 1. So we will try all the directions, right? So we have to go for all the directions. It means we'll make a loop and we'll check for all the direction. Let's for now we'll say direction, and direction will start at where? 0, and we'll go for all the directions, right? We'll say direction, right? It should be what? Less than 4 we have taken, right? If you remember 4. And then we'll go 4 directions are there. You can use the from the directions dot length, we can also write and that will come 4, or you can directly write the 4. Okay, and we'll say direction plus plus. Then what we should do, we have to find the next cell value, right? The next pair we can say. So we'll say int, you have to find the, let's suppose the current position is x, y is 0 0, right? For now, what is the next value? So this will call, let's suppose x1 x2 we can say. So we cannot say x1 x2, right? We can say similar to that, right? Let's call the int dx we can say, right? Direction x we can say. Direction x we have to find how. This is directions we have, right? And from here we'll pass the direction that we have given, right? And at 0, so we can get x. Similarly, we'll get the y at where? At 1, we'll write dy. Understand? We'll get the x and y. Now find the max. How will you find the max? Let's come here. To find the max, you have to use the math, right? This is what we have, max length equal to math dot max, and here we'll pass the max length and other values. You know how to find the you can say length, right? Let's suppose we reach to the next direction, right? We'll say 1 plus, means each cell will move, right? Means from the current cell, and if we go to the next cell, we have to add one length, that we know. And if the question saying no, if we move from one cell to another cell, and if the path length we have given, moving length, you can pass that length, this one I'm talking about. If it is given, means current cell to the next cell, this is the length we have, so you can use that length. Okay, but we have not given, so we'll assume this is what we have is 1, and as we have seen the example also. Okay, now think there is a DFS recursion function, you can see utility function, that will give you the I plus, will add the dx, next cell value, right? And we'll say j plus dy we can say. Okay, can we say that? We know that we have to pass I, you can say row, column, this is your row and this is your column, means next cell value. Have we took the turn yet or not? So we'll pass false, let's suppose, and then the what we thought expected or not. What is the expected value? So very first we found the 1 at line number here, we found 1, next should come 2 and then 0, right? We'll say okay, next we need expected is 2, and the directions, we'll use the direction. I hope you understand. This is what we have to implement. This is the method signature, and that's our job done. Only we have to recourse to the DFS. Okay, let's create the DFS. If we create the DFS here, how we are going to do? Very first, we know that let's write this one first, or you can say we'll take this utility method, so define as a private first. The return type should be integer, and method is DFS. We have to pass int I, that is the row, and the int j, that is our column, and then we have is boolean turned. Is it turned or not? That we will get is turned, we can say. It's good to write the correct one, is turned. That will pass, and it should be boolean. Then we'll pass the expected number, expected number, and then int directions. Okay, this is the method body. What I can do, I can write like this. Okay, now think. Very first, you have to check all the conditions. Boundary condition for row and column means the I should not be less than 0, right? The cell should not go beyond the bounds, and similarly j should not greater than equal to the columns, right? Can we say that? Now first we'll talk about the I value first, right? So I is less than or should not be less than 0, and it should not greater than or equal to rows. Similarly, check for the j. J should never be less than 0, and or should not and or j should be greater than equal to columns. It should not greater than equal to the columns. And we have rows, what do you call, the rows and columns at line number 5, right? That we can, that is why we have written outside. Okay, now we have to check the expected value is there or not. And the grid we already have, we have initialized the grid. We will say I and j means row or column. The row and column or the cell should not equal to expected number. Means I'm talking about this value. This value should not, if it is not here on the grid, so these are the boundary condition. If this is happening, means this is not good, right? It means we'll return 0 in this case, means we will not move. Now we have to flip the turn if we have not turned. Let's suppose we'll say flip turn will give the name, right? Flip turned state we can say, right? Flip turn state, yeah, you can write flip, or you just simply write the flip, you understands. So let's suppose we have a flip where we'll check is turn or not. If it is not turn, right, if it is equal to 1, if it is true, give 1, otherwise 0, right? So we can say current value, have we turned or not, right? That we can get here, and we'll give the name turned itself. Okay, are you understanding or not? Now find the expected value, right? From here we have to find the expected values should have the has, because we have to map it, right? To map it, we have to find the has value. Let's suppose each value should have has, and we can get how math dot max will pass 0 and expected thing I have, what I don't have. Let me copy from here directly. So expected nums -1 will do. Okay, so what we are trying to do here is we want to maps 2 to 1 we can say, and 0 to 0. Okay, now check the conditions. So now we should use the condition cases. Let's suppose how we'll write int and and we'll say what we have at memo at I j the has number that we have, right? Now first we'll take the t that we have turn. What is the turn we have? And then we say has number, and then the last we'll use the direction. Understand? These are the things we have given. And if it is not equal to null, correct, means we have calculated already. Don't need to calculate. Return this value. Return memo at this position that we are talking about. Correct? If not, if it is not calculated, means we have to calculate it. Okay? After this, we'll calculate it. Right? We'll check int. What is the next number should be? Find the next number. Next number, we'll know that this is what we have here, the expected number, right? If the expected number, how we can say, if we'll say expected number, if it is equal to what? 2. If it is 2, the next expected number is 0. Otherwise, it will be 2. Understand? So this is the next number we can get. Let's understand what is the current count or result. Let's say result count. Result count means current length, or we can say current path length. We can say path length is a good thing. Path length. How will find the path length? We'll say 1 plus. We'll use the DFS, the how we have done previously in this one. Remember where we have done here. Like this, we have to calculate again. Max length, path length, right? Max path length, you can say that name. You can say the max path length. Here we are calculating the path length. Okay. So we'll say 1 plus a DFS, and this is nothing but to direction, right? So, and here we are passing these values, right? Direction. Okay. So we know that very first we have directions we have. Let's call this 1. This is our I. This is our what? Directions we have to take from here, right? At D directions at where? At direction. And this should be for X, it should be 0. And similarly, we have to find for Y. Just change this value. It become 1. And here what should be their value? By default, will not say turn, right? What we have calculated the turn, right? That we have to pass here, right? Means, have we calculated the turn or not? Is turn, we'll say. This is what we have, is turn. This variable name should be same, okay? Is turn. Let me zoom out a little bit. I'm seeing this one, okay. Let's go a little bit up, okay. Next value is, if we have taken 2, we'll find the where next, what is the next number? So now we'll pass not 2, we'll pass the next number. And this is what we have direction. Like this, you will find the path length, okay? Now just you need to make the condition, have it turn or not. Let's suppose we have the isTurn method, isTurn variable, right? We'll check if isTurn is not true, means we have to find the new direction. Let's go for the new direction. The new direction. And we say that, and we can get from how we have the direction we have. Let's suppose we have direction we have. We'll add +1 each time for all the directions, and we'll take the modulus with 4, and we'll get the new direction. Now we have to calculate again the value, right? But this time we don't need to define again. We'll say path length like this. Okay, here we have to take the max between this and this and say math dot max, and here you have to pass the path length. What is the current path length we have, right? And this value. Okay, very first you will use the path length, then we'll use 1 plus DFS, I plus direction at 0, j plus direction at 1, and here this should be true because now we have to mark it as a true, and this is the next number and this is the directions. But this direction should be the new direction that we have calculated. We'll update it with the new directions. Okay, now what we should do, we have to update at the memo, so we know that we are returning at each time here, so we have to update this value. How? At here. So here it should be path length, and we say that, so we'll say memo at I, j, t, has them, and the direction, and this is what we have calculated. Now what we should do, we should return the path length at each time. If we have calculated for the first time, we'll return this path length, but if it is storing the if we are calculating the second time, right, it will return from here itself, line number 36. So, and as I told you, this is path length, so we should give the name. Here is a max path length, we can say. I'll give the max path length. I want to rename this name, so this will little meaningful name will be there, right? You can use this meaningful length. Okay, so that's all I have, guys, and let me know the comment section that you understood or not, and I'll see you in the next one. So another test case is passing and not failing. So this is 5.5, this is 5.5, this is 5.5. What is happening here? Let me check. Okay, so I found the mistake. What we should do, this is the piece of code we have to write again. Okay, where you have to calculate the path. We are calculating the path length, right? Where we have to write math.max, and we have to write what? 1 plus, right? 1 plus, we have to take DFS, right? And then we have to take I plus direction at this and this. It should be true, and it should be next term and the new directions. Okay, so that was the miss here. So I'll suggest try again. Use this. You can update this value, right? You can try. Don't do the format right now. Okay, let's try again. Okay, so all the test cases are working fine for me. Thank you guys, thank you for watching this video, and please subscribe this channel, and let me know the comment section that you like this video or not, and I'll appreciate your time. Thank you so much for watching this video.